Welcome back, everybody. Today we are looking at polymers. So polymers are another type of chemical reaction that we're going to be seeing happening. And when we're working with polymers, basically what we're doing is we're taking smaller compounds and creating enormous chains with them. So there's two types of polymerization that we're going to be looking at today. The first is addition polymerization. So when we're working with addition, alkenes is the word of the day. So we know that we're going to be working with double bonded chemicals, and those double bonds are usually opening up in order to create larger items. So we have something like this and something like this. The idea is that this bond will break, and so you've got a dot here and a dot here, and then this one will open up. So you've got your dot here and here. Instead of these two connecting together to make a pi bond, we say, okay, well, instead they are going to connect here. And so you get a longer chemical. That's what addition polymerization is. You guys need to be able to put these things together and take them apart. So because you'll notice I drew this guy right here, this is one of the most common sort of monomers in polymerization reactions that go through addition, polyethylene. So polyethylene, we've heard of this before, LDPE and HDPE. When you look on your bottles, you see that symbol. Those are the two recycle symbols for it. So 2 and 4. And basically what they're doing is they're just opening those C double bonded C's up. And depending on how they connect, so if they connect in a way like this, where there's sort of these big spongy gaps in the middle, that's what we call, oops, that's not what I wanted to do. That's what we call the low density, versus this one, we're going to see in the bottom one that it's high density because we can get lots of layers that are popping up there. So with that being said, we will look at an example of one of these things and some of the different ways that we can put them together. If we add different things, substituents to them, having trouble speaking, you could change the nature of it. So like I say down here, adding different things to the substituents. So if we add something like Cl to it, that makes PVC. And PVC is that white plastic pipe we see in irrigation, sprinklers, things like that. Lots of different plastic bags are made out of PVC. F is what makes nonstick pans and that type of thing. So we just like to add things to these polymers. So an example that I have here is this particular one. This is the monomer, the individual that is used in material that's really absorbent to water. So they tend to use it in things called water marbles. I think Orbeez is what some of you guys might know them by. And then like this stuff, the powder that's in baby diapers that can absorb water and swell up really well. That's what this chemical is. So when we go to draw it, sometimes the way that they present the monomer to you, it's confusing, but we gotta identify our double bond. That's the part that's going to be linking right there. So remember we said a long time ago with alkanes, alkenes, alkynes, when we're naming those, it's like spaghetti, they could bend. So what we want to do is take this and actually just, that should be an H, if you kink this down, so basically I'm just taking this portion right here and tipping it down. It allows for you to draw this material quite a bit easier. So if we take this and we move it in here like that, now all of a sudden this bond can pop, this bond can pop, so that you're getting a dot here and a dot here, and here. We can connect them. And so then what we do is we say, well, this is going to have to continue off out into the sunset, and the same over here. And instead of just showing many of these repeating, we put it in parentheses, and we just put an N down low. Okay? So that would be how we add these things together. This one we would probably want to do the same thing. You've got your double bond, just tip that C down. Then you've got your next one with a double bond, and we just tip that C down, and that way we can pop these guys open and connect them. And that continues on, and we're just looking at a small little piece. The N is telling us that it's just going and going and going. So that's our first kind. That is an addition polymer. And there's some different types, but you guys aren't around. I had some demos for this. We're just going to go ahead and skip over to condensation. So condensation is the second and last type that we're going to be talking about today. Condensation is a type of polymerization that's going to be linking molecules and creating water at the same time. So the key to this is that you absolutely have to have a carboxylic acid. You must have it. In addition to the carboxylic acid, you have to have one of these. You need the alcohol or you need the amine. Pardon me. Sorry about that. Choking on water. So we've got the alcohol and we have an amine. We need one or the other. So the way that these things can link together, you can have a copolymer, and with a copolymer, you're going to have two different types of monomers. Versus a homopolymer, we're just going to have one type repeating itself over and over and over again. So let's take a look and see how these things would link together. So nylon. Nylon is a material that lots of clothes are made out of. Lots of different things are made out of nylon. And it is made from two different things. So you can see this is a copolymer. So with a copolymer, we have here, we can see this is our acid. And then what do we have over here? We have our nitrogen groups. This is an amine. So when we look back, remember we absolutely had to have the carboxylic acid, and we needed either an alcohol or an amine. We got the amine. So we scroll back down, and what's going to happen is you need to make water. So where's the water going to come from? The water is going to take the OH from the acid. We are going to take the H from the amine, and these two things are going to come together to form H2O. And so now what we get is C double bonded O, and it's going to reach out. The OH is going to be missing. This is going to be missing. This is going to be missing. So what's it going to grab onto? The nitrogen. And then off over here, this is going to be C. So what do we got? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this is a double bonded O. And then we've got our H's, 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 and H's. Now, rather than do the same thing to the amine, I was running low on space, right? You notice that it's CH2, 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 right? It's the same thing repeating over and over again. This is an option right here. You can condense them together even more to save space. So rather than write CH2 6 times, we can kind of squash that down. Now, when we do this, remember that polymer is going to be many of these units repeating over and over again. So we know that this thing right here would be popping off and grabbing onto an H on the other side to make water. So this would need to continue on, but we're not going to show it, so we're going to put the parenthesis in. This one will be doing the same. This H is going to be coming off, and there will be an OH hanging out over here that should be joining it. And so that's what my polymer would look like for the nylon. We take a look at another example here. We want to take it apart. Draw the monomers that are used in taking it apart. So this is an example of PVC. You'll notice that we see the chlorines in here. So we know, as I look through this, I don't see any C double bonded O's. This is not created through addition polymerization. This or condensation. This is addition, not condensation, right? The condensation, we have to have this acid group. We have to have this amine, and I don't have any of that. I don't see any nitrogens here, no C double bonded O's, nothing. So this must have been addition. I must have had some double bonds in there. So the question is, where did they come from? We'll find the pattern, right? H, Cl, H, Cl, H. There would be a Cl here. So we've got this repeating unit, H. So I'm going to split this here. I'm going to split this here. So then that means there's a dot here. There's a dot here. There's a dot here. There's a dot here. So if I take this one little piece out right here, this would be my monomer. So now I have C with the H's and a C with the H's and a dot here and here. So what was my original monomer? Those dots wouldn't stay separated. They're going to come together and join to form my double bond. Oops. This was a Cl right there. And this was an H here, and this was an H here. So this was the monomer. And so this was addition. This is a really good example of a homopolymer, right? It's the exact same thing repeating over and over again. We don't have two different types like we had here. One more example here. So this is what we see in a plastic soda bottle. This would be I believe it's PET. So we would look at this bottle here, and we need to take this apart. We're asked to find the monomer here, or monomers. So find your type of polymer that it is. So when I start looking, I don't see any nitrogens, but I do see that C double bonded O right there. So remember that we had some options. You can have a C double bonded O, OH. You needed to have an acid. And then what else could we have with that? You either had to have an amine, right? Or, if we look back real quick, what was the other thing that we were allowed to have? An alcohol. And so we can either have an amine or an alcohol. And then this OH came off with either one of these, right? That made water. Or it came off with this guy and made water. And what would that leave us behind? An oxygen. So I would have had this left behind and this left behind, and there it is right there. So this is where my split is going to happen. And so then I would say that this is where my split is going to happen as well. Now, when I look at these, do they look exactly the same here and here? No, they're definitely different. This is a copolymer. And so we're going to go ahead and finish this up. So let's put this back together now. Let's find the monomer. So let's throw the benzene in. This is going to go to the double bonded O. And this is going to go to the double bonded O. And then what did it have to come off of there? This was the OH that went off to water. So there's my first one. So what does my second one look like? Well, my second one must be an alcohol. So an alcohol has got to have the O. So there's this one, and it must have split right there. So my second compound is going to be the OCH2, CH2, and then the O, and then we just need to put the H back on for my alcohol. So there's my acid, and there's my alcohol. Easy as that, right? So you're going to look for those groups. Do you see that carbonyl? If you do, there's a good chance that what you have to work with is going to be a condensation polymer. Now you have to be careful. If we look back up here at the first example I did, we had this going on here. So you've got to watch out. Sometimes you have a mixture of things and you have to choose which part am I going to go with here. And so in that situation, we did not have an acid. Right? There was no acid, so we couldn't take that apart. So we had to leave it the way it was, and we had to use that double bond instead. So look and see, do you have the acid and the alcohol? Do you have the amine? And that will guide you right to your answer.